Hello, everyone, and welcome to another Jakarta Tech Talk. My name is Serena, and joining us today is Arjan Tims, who will be presenting Piranha Cloud, a new EE/MP runtime in progress. If you have any questions for Arjan, as we move forward through today's presentation, feel free to ask it in the chat or use the Ask a Questions tab. Before we get started, the 2022 Jakarta EE Developer Survey is now open. I'll also include the link in the chat. Without further delay, Arjan, over to you.
All right. My name is Arjan. I'll be presenting about Piranha today. Okay, so I'm going to try to share my screen here. So see if this is possible. So just a second, share screen. And there's a lot of... Okay, so I hope this works right now. So it's not that easy, it seems. Okay, so do you see my screen right now?
Yes, we see your screen.
Okay, and also the full screen? No.
And no, we don't see the full screen. And yes, now we do.
Oh, I'll put it back to this. All right, there we go. So it's controls here are a bit difficult compared to some other, but it's okay. All right, so if you see the full screen now, we can start. So welcome to this Jakarta Tech Talk. It's about Piranha Cloud. It's a new Jakarta EE MicroProfile runtime. It's in progress. Okay, so a little bit about myself. I'm a 40 years Dutch developer from the Amsterdam region in the Netherlands. And I got my Master of Science degree in computer science from the University of Leiden, the Netherlands. So you see me there on the picture near my old OmniBeans office. So these are the projects I'm involved with: OmniBeans, Piranha Cloud, and GLASSFISH. So we'll talk about the relationship between those three a little bit later on. So I was previously a JSF and security expert group member. I'm a project lead of several projects: Jakarta Faces, Jakarta Security Authentication, Authorization, and some others. And I'm maintaining and releasing GLASSFISH in addition to Piranha Cloud. I'm also the co-author of 3 books: The Definite Guide to Jakarta Faces in Jakarta EE 10, which has just been released in a 2nd edition. Pro CDI in Java EE 8 needs an update soon, and the Definite Guide to Jakarta Security that's coming quite soon now. It's in the final stages of preparation. All right, so let's talk a little bit about the application server concepts before we dive into Piranha Cloud. Okay, so what's an application server? So this consists of a couple of points. So an application server is first and foremost separately installed. It typically contains an HTTP server, sometimes other servers. So this essentially means it listens to network ports for incoming connections and sends responses to those. Then an application server is a deployment target, so that's connected to the fact that it's separately installed. Means you send applications to them, typically archives, var archives, the most frequently used, but there are some others like EGB archives, not that much used anymore, and EAR archives. Then we run multiple applications typically on an application server, meaning it's kind of operating system for applications, for networked applications. Typically, we provide some kind of feature to provision resources. So this could be database connection pools, mail sessions, some security features like an LDAP resource, stuff like that. And that's quite important for this talk, it contains full stack API for consumption by application. So in case of Jakarta servers, application servers, that's the Jakarta EE API, of course, but in other servers or older ones, that could be other ones. So the really old things like Net Dynamics, if it was an application server 2, they had their own proprietary API there. But in this case, it's the Jakarta EE API. Okay, then we have some optional things, but they're quite typical for an application server to have. Some kind of GUI or CLI to administer the server. So you typically log in to an administrator panel, and this allows you to do those things we mentioned before. So set the resources, monitor resource usage as well, deploy and non-deploy applications, set some defaults for ports, for things, what have you. So that's typically done by either or both of these two things. And then we have typically some facilities for clustering. So meaning multiple application servers work together in a network to share load, to share resources across the network. So this is typically to improve performance or to increase availability of some kind. All right. So as I think many people know, there's been pushback against the application server concept. So one of the things that's most visible there, that you quite often see, is that an application server, partially by the simple fact of it being called a server, is maintained by ops at many organizations that use this or still do. So the ops team is typically in charge of everything having to do with server organization. So they typically install the network, they set up the firewalls, they install a Linux system, for instance. They take care of server management, maybe includes more memory, what have you, all those kinds of things. And the application server is typically included in that. And this means that the developers are not quite allowed to access it. So they just provide a var. We'll take a quick look at that, what that exactly is in this context. But they're not allowed to touch the application server. So just as they're not allowed to touch the network settings, they're not allowed to touch the firewall, they're not typically allowed to touch or interact directly with the application server. And this is problematic for various reasons. So there's typically a tension between ops and dev here, because big part of the application server are actually a dev concern. So things like the application server libraries, the implementations of the API that I just mentioned, but various settings as well, security configuration. It typically very much hooks into the application, and it's not that much of a separate concern. So this is always a great source of tension between those two groups. So even if you have a DevOps organization, it's better then, but then it's still problematic to some degree, because it's simply not a thing that's either ops or dev. It's always a bit between the two. So another point regarding the application server is that some of the features it offers are not always applicable anymore. So in a way, the application server was ahead of its time, since a lot of the features it offered are now very much offered by other things and quite popular at that. But they kind of originated within the application server concept. And at the same time, maybe partially because of being ahead of the curve there, maybe because it wasn't always that suitable in a technical sense, the shared hosting or the multi-tenancy capability, so the fact that multiple users run their apps on the same application server, that has always been a bit limited. So applications were shielded against each other. They were isolated, but not that well. They were executed within a single process. Isolation capabilities of a single process were managed by the VM, but not that well. So over time, the demand for that became more limited. And at the same time, you see there's other things coming up, like virtual servers. They provide a very strong isolation on a single physical server, so you could just deploy a single application to a single application server on a single virtual server and have extremely strong isolation between those two. Obviously, it does take a little bit of more resources to do that. So then there's this other development, containers, mostly in the form of Docker. They provide the isolation as well, not as strong as the virtual server, but they do provide it based on processes and their own file system and resources. So this is still way stronger than an application server could provide. And on top of that, Docker has a deployment model. So you could deploy your image, you could reference this to central repository, so GitHub. The Docker Hub in this situation. So this replaced a big thing of the application server. And then at the same time, there was Kubernetes coming up, and that replaced a lot of the clustering features of an application server. So taking all those things into account, application servers still have value, but their value can be diminished because of all those things mentioned here. So the last thing the application server contained that we just mentioned are the APIs. So in this case, the Jakarta EE APIs. And they have been, as seen, quite valuable. So there's a lot of things going on there. There's a lot of development in the Jakarta EE APIs. They've been going for a long time. They're very well thought out. They also have a natural split between the API and the implementation, meaning that the surface that you program against is quite small, it's quite confined and clear, as opposed to other products that have a not that much separated API and implementation. So you more it's easier to accidentally use a implementation specific thing there. And with Jakarta EE, this is far less the case. It can still be done, but it's not that often that this happens. And the thing is that Jakarta EE does not imply an application server. So a lot of thought is perhaps around the fact that they naturally have to be an application server, but it doesn't quite have to be. Like if you look at all the specifications, all the documents, it doesn't quite say that Jakarta EE has to be an application server. Of course, this idea is strengthened by the fact that essentially all certified Jakarta EE implementations, they are in fact application servers. Okay, so let's take a look at some other concepts here, which are jars. So what's to say about jars? So there's many variants of them, especially when looking at the ones where you run an application with. So James Faulkner, in a design article, quite expertly classified these. So there's skinny jars, there's thin, there's hollow, and there's fat or Uber jars. And they get increasingly more complex. So a skinny jar is essentially, it contains only the code that your application consists of, and basically nothing else. A thin is almost the same, but it contains some app dependencies. So a skinny jar would only contain, for instance, the Jakarta EE. dependencies as provided, so it links to them, but it doesn't include them. The thin jar would include some of your app dependencies, like Guave or something, or Apache Commons. Then there's the concept of the hollow jar. So that's essentially the inverse of a thin jar. It contains kind of a pre-packaged app server. So this can like be very literally an entire application server just packaged as a single jar. And then there's finally the fat or the Uber jar, where you have essentially a single jar containing everything. So you just run the jar and your application server, your HTTP server dependencies, everything is in that single jar. And there's a picture there that kind of shows it. Okay, so some examples, we mentioned a few of them before. So a Skikini jar is essentially a var file. There are some other examples of that, but the var file is the most well-known ones. It only provides your application code and it uses only provided APIs. So this are, for example, the Jakarta EE APIs here. The tin, that's mostly a var file as well, but it contains some non-provided APIs, and this means that the libraries that contain this code are included in the lib folder of the var file in this case. And a var file is essentially just a jar file as well. It's just another extension, but it's technically a jar file. Okay, a hollow example. So that's, for instance, Piranha Micro. So that's the full or almost full Piranha server, but it's repackaged as a jar file, missing some features that are explicitly left out, but it's mostly the full server. And you use it to run a single var file on the command line. And then the Spring Boot is perhaps the most well-known example of the fat Uber concept. So you compile your application, it results in a single jar. You run the jar file on the command line and you get the full application, including the server bits and everything else. Sometimes you have a bit of a hybrid between them. So that's Helidon, for example. So Helidon results in a jar file, but the Helidon jars are not packaged within the jar. They are directly referenced on the file system. So you still have the concept of a Uber jar. So you just say Java minus jar and then the name of the application. But the jar files are not technically in the Helidon jar. Okay, so let's now take a look at Piranha Cloud. So Piranha Cloud essentially traces back to late 2017. That's when we started with some of the concepts. But we started for real in 2019. So that's where the bulk of the development started. And one of the things we focused on is that we wanted to build it up from the ground to support Jakarta EE, but without being the application server. So essentially the most minimal support and still run Jakarta EE applications. Have a very low amount of glue code, have a very low amount of service and management code and what have you. So just as much as possible is plain Jakarta EE code. And in order to do that, we introduced this concept of being modular with respect to the application server features. And those are the features we just talked about in the previous slides. So I'll show an example of this here. So this is the typical stack that we have. So we have Piranha Server, Piranha Micro, A, M, Embedded, and NANO. And they increasingly add features, or if you look at the other way around, from server and then top down, they remove the typical features that you have in the server. So Piranha Nano here. It runs on a flat class path. So you just include it in your main application. And it presents you with a subset of the servlet API. Say a programmatic setup. We'll take a look at the example there. Then embedded builds on Nano. It adds a little bit more things to be able to offer a full servlet API. So it has things like listeners, a HTTP session, which are not present in Nano. But it's still a programmatic setup. So you add it to your main application. You call it from a main method, for example. And then you programmatically set up the thing and load stuff with it. Piranha Micro M, so that's a minimal version of Piranha Micro. That's essentially, it feels a bit like the hollow jar approach. It's a single jar. It runs a var from the command line, and it includes the HTTP server. So it's functionally quite similar to something like Piranha Micro. Then there's one version on top of that. It's Micro A. It includes all. That's where the A comes from. And this one has an isolating class loader and a so-called Maven dynamic component loader. So this sounds fancy, but it means that it doesn't include all the libraries that make up Piranha Micro, so things like Soteria or Mojara. But it just loads those things dynamically via Maven. And Maven can have them installed on the local M2, so then it's just loaded locally, or it can come from the network or a private repo or what have you. So this makes it quite dynamic. And we were using Maven for this because people have all those libraries typically available in their Maven. They're known with Maven. They use access to manage the dependencies. So this was quite a convenient, almost protocol file system thing to reuse. So we did that. And then finally we have Piranha Server. So that's the thing that's most similar to a typical application server. So it's an install thing. You can deploy and undeploy things to it. You can start and stop it. You can have multiple apps to it. And optionally, you can have some stronger isolation between the apps. Although this does come at the cost of more memory. So isolation here means that every application running on it has its own copy of the server libraries. So that obviously takes a little bit of memory. Okay, so here we see a graph that kind of explains the thing. So on the right we see those 4 versions that we talked about before. So we only show Micro A here and not the M, but the diagram is mostly the same without it. And then we see that they all build on top of each other. And then eventually that the archive loader from Micro uses Maven and shrink wrap to load a specific set of Jakarta libraries, and those are the ones in orange there. And the isolating class loader means that everything runs within its own class loader. So if you use it for embedding, it typically or almost doesn't touch the environment. There's a few exceptions there, but it typically runs fully isolated. And compared to other embedded solutions like GLASSFISH embedded, it's not influenced by things already on the class path. So it won't load initializers, or it doesn't pick up beans, it doesn't scan other things on the class path. It's almost like its own mini VM, so to speak. Okay, so let's take a look at some code examples here. So we have Piranha Nano here, sorry. And code like this is typically run from a main method. So you could also use this in things like a cloud provider environments. So look at the right word. It's a function type of thing where you essentially get called by your cloud provider server. You don't deal with HTTP stacks within this code. You just get a request in. And Piranha doesn't deal with this either. So it's just a small facade, so to speak, to give you a familiar servlet environment, but still within the confines of a cloud provider. So you could use this in your main application as well, a local command line application, but this is typically used for functions in cloud providers. So you see it here, building up a request to a servlet that you have and then executing it. Okay, so we move on to embedded. So embedded deals more with libraries. They're still on your class path. It gives you a more complete servlet environment, but it's not isolated. So like you see here, we initialize it via a Mojada initializer class. This comes from the class path. It's just a thing. It comes from Mara. Of course, you have to know that this exists. But it doesn't do any scanning. It doesn't do any standalone running. You have to compose this thing programmatically. And you can, in this case here, give it a slit page, and then you get the result from it, which you could store into a string. You can store it somewhere else. You can send it to the request or whatever. Okay, then take a look at Piranha Micro, sorry. And here it's used as the embedded, in the embedded version. So we have an isolated class loader environment here. So it doesn't pick up things from the class path. So we give it the thing it needs via Maven coordinates. So it needs two things here. Jakarta Faces, which is the Mara implementation, and the Jakarta WebSocket API. So when this here runs internally, it will load those things via Maven. So this could be on the class path. This could be on the file system. It could come from the network. It depends on whether you already have these dependencies. And internally, this will take up memory, of course. So this is something to take into account. Otherwise, you have a perfectly isolated system here. So one specific thing I quickly wanted to show you is that there's a security infrastructure. So I hope this comes across. It's a little bit of a complicated diagram. But Piranha Cloud does not use security systems layered on top of each other, where the Jakarta authentication, authorization, security things are, so to say, facades on top of a native security system. So it uses everything quite directly. So if you look at things like GLASSFISH, it has its own authentication code, and then Jakarta authentication is layered on top of that. Other servers go even beyond that. They have an authorization system themselves, and everything is layered on top of that. And the Jakarta APIs are mostly just compatibility APIs. So Piranha Cloud does it a little bit differently. It doesn't have this layering of security systems. It just uses those things quite directly. So that's a nice feature of it. Okay, so one of the things is obviously, since I'm also involved with GLASSFISH, how do those two projects relate to each other? So Piranha Cloud, even though it technically doesn't have to. It can run with whatever components you give it. In practice, all the default distributions that we have, they use the GLASSFISH components. So this is done on purpose, so that the two projects remain quite aligned with each other. So it's almost as Piranha Cloud is a dynamic modular version of GLASSFISH, even though the server code is completely different. They don't share that. So they only share the components, which are things like Mahara, Jersey, Soteria, stuff like that. So not all the things that GLASSFISH has as code was available as separate reusable components. So things like the authorization code, the authentication code, the transaction manager, they were internal to GLASSFISH. Other things like JSF phases were used as separate projects and components. So one of the things we've been working on is to extract these components from GLASSFISH. So Exercia is for the authorization, has been done before, and that's now used by both GLASSFISH and Piranha. But two other projects, Ilias is coming up. So we have extracted that. It's not yet submitted to Eclipse as a project, but it's already used by Piranha. And GLASSFISH uses the original code still, but the idea is for GLASSFISH to use that one too, so they're actually shared. And the transaction manager is planned for the same thing. So some investigation there, but nothing fully concrete yet. But the idea will be that Piranha will eventually use the same transaction manager as GLASSFISH does. Okay, so one specific thing, and this is mostly for compatibility with GLASSFISH, is the concept of enterprise beans. So enterprise beans have a kind of a difficult history. So the original version was not that good, so people started to hate it, and there was a newer version coming. It's already a long time ago, in 2005. Enterprise Beans, Jakarta Enterprise Beans 3, at the time called EGB, which was way better. But it's still, even today, it's still a different component model than CDI. So there's two of them, which makes it kind of difficult. Enterprise Beans doesn't have that much development anymore, so there's not many enhancements going in there, or actually none at all. There's not a really active team around it, but still a lot of existing code makes use of it, and you need it for certification, specifically for the web profile, which we aim to certify for. So what we've done, we started a new Jakarta Enterprise Beans implementation. It's still quite early, but the idea is to fully base this on CDI. So everything that Jakarta Enterprise Beans offers is re-implemented using CDI features. So, for example, we have this bean over here. It runs on Piranha Cloud with this EGB implementation, but there's no real EGB code. So everything here is essentially translated and mapped to CDI concepts. So the asynchronous here is a CDI interceptor. Stateless is being mapped to a custom scope, etc., etc. And we're doing this currently in the OMNIBEANS project. So eventually this will move to somewhere else, but it's currently done over there. So this will make Piranha Cloud hopefully compatible with Enterprise Beans Lite. So we're not going for the full. That's way too much work. Also not much demand for that. But we feel that Lite should be achievable. And then hopefully we can achieve the the web certification. Okay, so that's basically it. So there's much more to tell. So things like the compatibility that we currently have with the servlet TCK. So I think that's like 98% or so. We already certified for MicroProfile JWT. So a lot of things are already working, but not everything is yet. So it's still very much in development. All right, so that's it. Let's see if I can stop the screen sharing here.
Arjan, there's 2 questions for you. If you scroll over to the Ask a Questions, would you like me to read them to you, or would you like to address them yourself?
All right, so let's, yeah, you can read them to me. That might be convenient.
Sounds good. So the first question is from Carlos Gonçalves, and it's, does this mean that nowadays with K8s plus Docker, an application server is no longer useful? Rather, just package the whole thing into a fat jar and deploy a Docker image with it?
Yeah, so that's indeed the part I was addressing in the first part of the presentation. Application servers have diminished use, indeed, with Kubernetes, with Docker, with virtual servers. Much of their initial value is gone if you use that environment. On the other hand, not everybody uses that environment. Kubernetes has its own difficulties, it has its own problems, and not everybody likes it. There's difficult configurations. So the application server itself still has value, even if you combine it with Docker, say, to only use a single deployment, so a single application to the application server, where you have the application server in one layer of Docker and the var file in another layer. It's still a convenient way to separate those 2 things. But yeah, so you're partially right. It's not always useful anymore, and that's why we came up with Piranha Cloud. But there are situations where it's still convenient if you don't want to deal with Kubernetes and clouds and what have you. Then the application server in its traditional setup, running multiple applications on a single process, it can still be useful. So it kind of depends on your use case.
Perfect. And then the second question, also from Carlos, is also Jakarta EE has many specs. Is it web profile compatible? Which ones does it implement or plan to?
Yeah, so I briefly touched upon that in the last slides. So specifically the EGB compatibility thing was related to that. So yeah, we plan to be web profile compatible. That would be the first thing, and be compatible with my MicroProfile as well, and probably the core profile too. So currently, one of the things we're working on is the servlet compatibility. That would be the first step for us to take. And we're quite far with that, so that's at 98 something %. But there's a few small issues that are quite difficult to do. They're quite time consuming. So once we have servlet compatibility, we could quite easily go beyond that. So things like JAX-RS, Jakarta REST, Jakarta Faces, they run on that. We use the existing components for that, so then compatibility for that is quite easy to achieve. But enterprise beans is difficult for the web profile certification. So that would be the next big challenge for us to work on.
Perfect. And then there's just further clarification from Carlos. So he says, what I mean with the first question is, if a developer is just coming to Jakarta EE world, should one forget about traditional application servers like GF pariah or wildfly and just turn to things like piranha, hildon, or quercus because of Docker plus K8s have replaced their deployment models?
Yeah, it's a good question. So I'm not entirely sure about that one. So a traditional application server, if you just start out with development is still quite handy. I mean, you install it in, say, Eclipse, you deploy your var file to it. It's easily to debug. If you come new to the Jakarta EE world, you could still start with it. It doesn't matter that much. So the most important thing for you would be to learn the APIs and the fact that you have several deployment options. So you could use it via a hollow jar type approach, Uber jar type approach, or you could deploy it as a slim jar. But you would just have to know that you have these options. If you're just new and want to learn the APIs, then it's mostly about the APIs. And then you can deploy to either, or you can use either model to deploy.
Perfect. So I think that is it for questions in the Ask a Question. So I just wanted to thank you for the excellent presentation today. And just a reminder, if anyone in the audience has any final questions, please feel free to ask them in the chat or Ask a Questions tab. I'll give you a few moments to do that while I wrap up. So the next Jakarta talk happens on April 12th, implementing Servlet 6.0 in Jetty. So you can register for that session using the link I will be posting in the chat shortly. We're also looking to book more Jakarta Tech Talks throughout 2022. So if you're interested in presenting, feel free to fill out the form that I'll also be including in the chat as well. And finally, if you have any feedback on the Tech Talk program, we would love to hear from you. Just click the green button that popped up and let us know how you enjoyed the talk. So thank you again, Arjan. It doesn't look like there's any other questions.
I think I see one last question.
Let me see here. Oh, in the chat? There you go.
Yeah, so when is Piranha expected to be production ready? Okay, so yeah, that's a very good question. So it's currently mostly a off-hours project. So I feel it should start to become production ready when we pass the Servlet TCK, so around that time. So it's probably still a few months. It's not very long anymore, but we would expect it to be, I don't know, there's the end of this year, approximately, something like that.
Perfect. I think that's it.
All right. Thank you very much.
Thank you so much. And everyone, have yourself an enjoyable rest of the day. Take care.
All right. Thank you.
Thank you. Bye.